Well, welcome again, everyone. This is Friday, so I appreciate you all joining us. So today we're happy to have Eddie joining us, and this guest lecture from Eddie is part of our course AI Evals Analytics Playbook, Maven. So I'm Stella Liu. I am head of AI Applied Science in EdTech. Worked in tech for 15 years now, and previously worked at companies like Shopify, Carvana, and various different startups. And also my partner Amy here, who is also a very experienced AI developer. I spent 10 years building AI in production, and we co-founded this organization called AI Evals Analytics in 2025 and started doing a lot of content creation, training, and also consulting in this very new space of AI evals. Let's see who else we have in the waiting room. Okay. Yeah, but today we're not going to talk about our course, but instead we will have Eddie here to share with us a research that he did recently on AI evals and how to align LLM-as-Judge with human evaluations, which is a very important topic in AI evals. But before I hand it over to Eddie, I want to maybe set a stage a little bit and give some context. So in our AI Evals and Analytics Playbook course, we once showed this diagram with our learners. This is what we call a judge workflow, and this is a best practice for doing as a judge today. For many of you, if you have experience with AI evaluations, you probably found out that tweaking evaluation prompts can be very painful. And the whole point of doing LLM-as-Judge, again, LLM-as-Judge is cheap, is fast, and is easier to implement compared to human evaluations. And the whole point of doing LLM-as-Judge is to use judge model, which are usually language models, as a proxy for expert or human evaluations. So you started from defining your metric and defining your rubrics with subject matter experts, with stakeholders, and then before applying all that to your entire test set with your entire data set, you want to do a test run on a small sample set, and then review that with your human experts to make sure that the results aligns with human judgment before you apply it on a large scale. So this is a slide from our AI Evals and Analytics course. And again, it says how critical it is to calibrate such to align with human judgment. And in our course, we recommended working with human experts. And Eddie today is going to share with us a new method that he proposes. I would say it's a more statistically rigorous approach for doing this calibration, LLM-as-Judge calibration. So with that, I'm going to hand it over to Eddie. Let me stop sharing and then you can share. Okay, take it from there, Eddie.
All right. Can you see my screen? So first of all, happy Friday, everyone. Thanks so much for joining today. As Stella mentioned, I'm going to be talking about LLM-as-Judge, and in particular, how to make it reliable and how to leverage its benefits without getting into trouble by putting too much faith in it. So first, I'll talk about just a little bit of background on myself. So I also have been in the data science machine learning world for about a decade and a half. I spent a lot of my time focused on bringing economic statistics and causal inference to business problems. I spent time in advertising, spent time in recommendation systems, a lot of related areas, but always with an emphasis on careful measurement. Worked at both big companies and small, Stitch Fix Salesforce, and also most recently a long-term memory system company. So yeah, starting out with just what I'm going to cover in this talk. So first is a little bit of problem framing around, hey, what problem are we actually trying to solve with AI evaluation in general? Motivating why I think that LLM judges are very useful and powerful, but when used naively can go terribly wrong. And then the fix that I propose, effectively calibrating the LLM-as-Judge to human experts or whatever you deem as ground truth, and then I'll talk about some of the results we see in practice, some of the experiments I've run, and some of the tools you can use to accomplish this in your own workflow. The first thing I'll talk about is the way I think about the evaluation problems. So, evaluation problems have existed for a very long time. So if you can think about testing a new drug, right, and the effect that has on people's health and whether it's effective and the health effects, that's another evaluation problem. And so in the case of LLM-as-Judge and AI evals in general, it's just a special case of a pattern that's existed for a long time. And so, a dynamic I've often observed is that in almost any domain, probably most people here are from a business domain, you have some North Star, what I call Y star, your ultimate objective. In a business case, oftentimes it's something user LTV or discounted cash flow, something that, you'd have to run an A/B test for years or something that to actually measure. So typically you can never directly measure the thing that you actually care about the most. And so you settle for what I call Y, and I'm going to use the term oracle in this context, which is basically something that's, hey, it's not perfect, but it's a pretty high quality approximation to what you care about. So, for example, average order value or whether people are signing up for the service, maybe you run an A/B test on that, and right, that's the thing that you can practically measure that maps to the thing that you care about. And so the way I think about LLM-as-Judge within this framework is that it actually lives further down the ladder. So it's actually something that's much cheaper than running an A/B test and being able to collect signups. And so the question becomes, how do we use the data that's available? How do we use the judge along with a more expensive measurement, for example, humans, to learn about the effects we're having on the thing that we care about? And so, the gold standard here, and probably most people in this meeting are very familiar with A/B tests, but essentially, what you're doing in an A/B test, let's say you have your website. The classic example is either your website is green or it's red, and you want to know what the better experience is for users. Maybe you want people to sign up for your website. So what you really care about measuring is what Y star would you see? What would the long-term outcomes be under green? What would the long-term outcomes be when you imagine those two parallel universes? And so the problem with this for LLM evaluation is that it's way too slow and it's just completely impractical for most teams. Most teams don't have the traffic, they don't have the sophistication. And also, the LLM space moves super quickly. So if you run an A/B test on the newest model from Anthropic versus the last one, right, by the time that A/B test ends, right, they probably will release a new one. And so we need something that's faster and that can work offline. And so now I'm going to talk about why I think LLM-as-Judge is inevitable. And it's really, it's a paradigm that can go wrong, but it's a paradigm that is really worth embracing. And so just talking about the superpowers of LLM-as-Judge, human labels are extremely expensive. Let's say you're working on a coding assistant or something like that, right? Ideally, you could hire a bunch of super senior software engineers to do extensive code review, but experienced software engineers are really expensive, right? And the amount of code that gets generated from these tools is crazy. So it's just completely impractical to expect that human experts could do all the labeling.
Mm-hmm.
Go ahead.
Oh, sorry to interrupt.
Yeah, go ahead.
There. Just want to add some numbers to what we mean by human labels can be very expensive. The example Eddie mentioned, if it is a coding agent hiring a software engineer and an experienced one can be very expensive, and we all know that very well. And an extreme case that I learned was getting X-ray labeled. And that was, I believe the number I heard, that this was 1 or 2 years ago, it was $2,000 per sample. So it can get very expensive.
Yeah, and that's, also just managing humans is hard, right? Giving them directions and it's slow and, right, so they're just thinking about it as the cost of running an LLM-Judge and changing the prompts and adjusting and adapting it to what you care about is just, it's not even a comparison. It's orders of magnitude easier and more efficient than human labels. But the problem, which is probably why most people join this talk and are interested, is that there's no reason to expect that an LLM-Judge cares about the same thing that you care about or what your business cares about or what your users care about. And so I'm using this Y star as kind of your gold star, what you really care about. And so an LLM judge, if you just kind of ask the judge what they think, right, they're going to give you a very confident answer, but it's going to have preferences that are very different from the ones that you care about. And so, it's very well documented in the literature. If you give an LLM judge a long response and it has no more substance, it'll systematically rate that higher than effectively the same material in a shorter response. They prefer generations. They prefer answers that were generated from themselves. If you use an LLM judge, let's say it's a GPT-5 LLM judge, and the policy that you're evaluating or the prompts that you're evaluating is also using GPT-5, and you're also comparing it to another model, the GPT-5 judge is going to say, oh, wow, that's exactly what I would say. This is just a small sample of the kind of biases that we see pretty consistently in practice when just relying on the judge by itself. I think the sycophancy in language models is a great example of the kind of errors that you see when effectively, I think of an LLM as judge, and the problems you run into is basically using a proxy metric that isn't well calibrated to what you care about. I think the labs have done a better job of getting their models to be less of sycophants, but probably at some time they ran some evaluations and maybe it was LLM-as-Judge, maybe it was just short-term human labels. But, basically what they were saying was, okay, great. The sycophant, you're absolutely right. And people love when you say that, right? And then a couple of weeks later, right, the actual long-term human outcomes, for example, people using Claude Code, right? They were trying to get advice on, hey, should I build this thing? Should I design the system this way? This is the way I'm thinking about it. And right, if the AI assistant was just telling them that everything was a good idea and that they're brilliant and invented something novel, right? That's, maybe at first that seems good, but actually that's very destructive. And I personally ran into issues where I just had a code base complexity explosion and just had to completely nuke a code base because of this behavior. And so the fix that I propose, and I think is also just very well grounded in very mature statistics and how policy evaluation has been done in other fields, medicine and economics. The best way of achieving this is basically learning the relationship between the LLM judge and the human expert labels. And it doesn't have to be a human expert label. It could be something else. But in this case, for the sake of this talk, I'm going to mainly refer to it as a human label or an oracle label. The way this works, the visualization I show here, and this is basically the open source framework that I built. It's called CJE, or causal judge evaluation. And if you look at the top here, the first step is collecting a small set of examples. So this is, you can see a set of inputs and a response or answer or output that the prompt and model, when I say policy, I'm talking about a system configuration. So that would be, what model are you using? What's the system prompt? What retrieval are you using, et cetera? And so for this small slice, you want to collect both what the LLM judge says and what the human oracle says. And then once you have these, you're able to learn that relationship. You're able to calibrate the LLM judge to what the human actually cares about. And then once you understand that relationship, you can just, put the LLM judge to work and have it label thousands of data points, right? And so you can see here, you can label thousands of data points, but you're still unobserved on what you actually care about, which is, what would the human think about this? And so that's where learning that relationship comes into play. You use that relationship to predict what the human would have said.
Quick question, Eddie.
Sure.
What if after we run LLM-as-Judge evaluation and also collected the human oracles on this small oracle slice, and it turns out there is zero correlation between LLM-as-Judge and human oracle?
Yeah, that's a real problem. I might talk about that in the next slide. Let me see what. So yeah, first, calibration, maybe it sounds technical jargon. And maybe it is, but really the simple way to think about it is it's just a translator, right? It's Google Translate. The judge speaks one language and you speak another. It's the judge thinks that things that are long and complicated are good automatically, and the human probably thinks the opposite. And so calibration is basically a translation layer. And so here you can see the judge says 8, and it's got this reading this long response, and the human thinks that's much less impressive. And so, yeah, this is getting to Stella's excellent question directly. You definitely should not assume that your LLM judge is going to correlate well with what you care about. And one of the real benefits of calibration is that it'll keep you honest in acknowledging the extent to which you can learn something about what humans would say just using the judge. And so, yeah, the workflow that I recommend when you're first standing up a judge and you're figuring out how to design a rubric or how to prompt it in a way that does correlate well with the thing that you care about, what I recommend is basically you take this small data set where you have both the human labels and the LLM judge labels, and you train the calibration on half of it, and then you predict on the other half. So for the other half that you're holding out, you have the oracle labels, you have the human labels, and so you're making predictions about them. And then basically you look at where the biggest differences are between the predicted oracle value, the predicted human label, and the actual human label. And you look at examples on the basis of where those residuals, where those differences are the biggest. So basically you look at where the judge is missing the human to the greatest degree. And what I recommend is using your human judgment and get an understanding for the data. Looking at the data is always, that's one of the few recommendations that turns out to be always useful. And so, yeah, my recommendation is focusing on those examples. In my experience, they often tell you exactly what you need to change about the judge, what it's missing that the human is picking up on, and basically incorporate that into your judge, rescore, and hopefully you'll start to see a real relationship there. A couple extra bonus benefits of using this framework, taking calibration seriously, is that if you've ever run an A/B test, right, one of the first things that people ask about is, is the result statistically significant? Can we end the test, right? And so people care a lot about that in that domain, right? That's maybe A/B tests are a little bit higher stakes. And so you want to have, maybe the p-value of 0.05 really makes a lot of sense in that context. I'm not being overly prescriptive about how much certainty you need to ship A versus B, or that's a very domain specific problem. But what I can say is that without calibration, even if you have confidence intervals, they don't really mean anything. And so you can generate the right answer to the wrong problem, is the way I think about it. Without calibration, right, you can generate these confidence intervals and you say, ship the sycophant, right? Policy A or policy B, statistically significantly better. And actually have it be the case that those confidence intervals just meant absolutely nothing. And so what calibration and the CJE framework gives you is it gives you the alignment, but it also gives you the uncertainty with respect to the question you actually care about. I saw Stella unmuted, so maybe I'm not sure if she had a question.
No, I have a cynical comment that I'll save it for later.
Okay. So yeah, just a practical heuristic or starting point that I would recommend in terms of how much data you need. I would aim to have 100 human labels or 100 human expert labels and see where that gets you, and maybe multiply that by 10 in terms of the total examples. But I wouldn't say this is just general guidance. It really does depend on your data set, and in particular, how much signal your LM judge has about the thing that you actually care about. If it has a lot of signal, if it's very well correlated with the thing that you care about, right, you need a lot less data. In particular, you need less of those oracle samples. And so something that CJE does, and something that I think is really underappreciated about quantifying uncertainty in the proper way, quantifying uncertainty, while it helps you make good risk-adjusted decisions, but even beyond that, it has direct implications for basically how you should make these decisions, how many examples you need to label, and how many of those examples should be labeled by the expensive labeler. And so I'm not going to get into any of the math here, but I have a Colab notebook and happy to discuss the details with anyone else later. But effectively, we're able to separate the sources of uncertainty. So one source of uncertainty is how many total examples do you have? And then the other source of uncertainty is how confident can you be in the relationship you learn between the LLM judge and the expert? And so that's how many expert labels do you have versus how many total examples are you using? So when you have both of these quantities, you can actually derive the optimal label budget, and that can save you a lot of money. And so basically, yeah, what the interface to the user interface to this is basically you say, hey, this is how much money I have to spend. This is how much I'm spending for each judge label, and this is how much I'm spending for every Oracle label. And it'll basically just spit out, hey, here's how many total examples you need, and here's how many you need to label with a human in a way that minimizes your uncertainty subject to that budget constraint.
If I may interrupt here,
Sure, yeah.
this is maybe a good timing to drop one question from Harsha.
Sure.
Harsha asked a question about what judge model would you recommend, or if you can share some experience or observations of the differences between different judge models.
Yeah, it's a great question. I think the correct answer is one that's sometimes not very helpful, which is it's very domain specific. And so if you're very cost sensitive, right, maybe you use OpenAI's GPT Nano, for example. And in fact, in the experiment that I ran for the paper, we used that as the judge model, and it worked fine. That said, if you're trying to approximate something pretty nuanced, and it's a real commercial product with real scale, I would just recommend using the best frontier model. From what I've seen, there's not consistent reason to believe that Anthropic is better than OpenAI versus Google. I think just, I probably wouldn't spend too much time comparing those models, and just pick one and focus on how you're prompting the judge and developing your understanding of the problem and this framework.
Yeah. If I can also maybe
Sure.
add, there are also companies where teams training specialized models as judge models. I'm always a little cynical about that. I call it the Matryoshka problem. If you're training a new model to be your judge model, then are you going to evaluate your judge model? And then it just becomes a never-ending problem. You will always need to do evaluations for any new model that you add to this chain. But for Harsha also asked a follow-up question about for domain AI applications, say if it is an AI application in healthcare, is there value in using specialized models such as Met Gamma, etc.? So I think this, again, it also speaks to how important it is to validate with a test run or do the calibration using the method that Addie proposed to get a quick pulse on how good this judge model is in terms of consistency and also in terms of how well it aligns with human judgment. So I personally don't have experience working with Met Gamma, but it applies to any judge model that you pick.
Yeah. Just the only thing I'd add to that is it's really an empirical question. And so if you're really focused on answering that question well, something you can do is just, right, if you have your expert labels, you can use both and get the judge scores using both models for every example. And then you can just see which one has more signal, which one is more correlated with the thing that you care about. And yeah, I'd probably be skeptical, in the same way that Stella expressed about some company claiming to have fine-tuned some model to be the perfect LLM judge. I mean, it's possible, but it's an empirical question.
Yep.
So I started just getting into, okay, how does this work in practice? What benefits are you seeing? In the paper that describes this methodology, we ran a large-scale study in which we basically used an inexpensive model, the GPT Nano model, to approximate the judgments of a much more expensive model. So, a GPT-5 reasoning model. And so, ideally we could have had the human experts, but I think the statistical properties and takeaways are still consistent. And basically what we saw is that we were able to reduce cost and get effectively the same quality of evaluation, 99% of the ranking accuracy, choosing the best policy by using this approach and using the GPT Nano model for 100% of the examples, and reserving the expensive reasoning model for just 5% of the examples. And we went from talking about the confidence intervals and what I illustrated before with the toy example, we actually saw that without calibration, confidence intervals, even calculated in a way that a statistician would approve, the right answer to the wrong question basically captured the true value that you care about 0% of the time. And so that's a failure mode that we saw in a pretty catastrophic way. And so those are pretty strong claims in terms of increased efficiency and reliability. And so just trying to help provide some intuition into why this works so well is I think that the real strength of an LLM-Judge is that they're really inexpensive. So you can collect a lot of data, so you can get really precise estimates of the thing that they're measuring. Unfortunately, they're measuring something random or something that's not closely related to what you care about. For the Oracle labels, they're really expensive, but they're pretty true to what you actually care about. So because they're so expensive, you can't collect many of them. And so they're to think of them as they're aimed at the right target, but they're very dispersed and noisy. And so basically what this calibration framework does is it leverages the benefits of both. So you get the precision, and then you're able to systematically adjust for the bias of the judge using that small sample of expensive labels. So yeah, I'm not going to spend too much time on this, but this is just the CJE library, and the calibration code is on the left to basically learn the relationship between the judge and the oracle, and then on the right is just some code to get that optimal label recommendations in terms of how many examples do you need, and also how many of those need to be labeled by a human. Just a quick note on the major ways this can break and the things to look out for. And I think this is also very related to the syncophancy failure mode. And I also view these as very consistent with the things you need to look out for in an A/B test, is that, things change over time. And so people might have liked syncophancy at first. That may have even tested well in an A/B test, but that changed over time. And so that requires you, or that necessitates some collecting more labels on some cadence and making sure that the calibration still holds. And if it doesn't hold, updating that calibration. And then, the second thing is just making sure that your evals are actually representative of what you care about, of your actual users and the actual tasks that your product is trying to solve. And so, that's the talk. Thanks so much, everyone, for joining. I think the main takeaway is just that, I somehow I was able to talk a lot through this presentation, but it's a pretty simple idea, Just a small investment in good human labels can make the stupidest LLM judge trustworthy. And calibration is just what you do to correct for the bias and show you how to improve.
Yeah, this is very solid work from Addy. In AI evals and also in other fields, other spaces, you often see people build something really simple and try to explain it in a very sophisticated way. And Addy is actually the opposite, I would say. And I love it that when you put out the two assumptions to watch out for. And that also aligns with the philosophy we have in our AI Evals Analytics Playbook course. A lot of the time, people try to simplify it, which can be very helpful when you're first entering into the space. But in practice, when you try to apply all those to real-life projects, there are a lot of things to watch out for. And that is what Addy's work is trying to address, and also that is what we share a lot about in our Maven course. And we have some great questions in the chat. I will try to get to most of it, but if not, then I will also share a link in the chat. You will be able, and in the after follow-up email, you will be able to book some chat time with us, with me and Amy, if you have any additional questions. But let's try to get to them. The first question, there's one question from Harsha asking if this work, the CJE work, can be applied to multimodal evaluations.
Yeah, it's very general in that way. It can be applied to multi-turn. It can be applied to multimodal. Basically, you need to be using a judge model that can effectively take the different inputs. So I guess to some extent, it's just dependent on your setup. But CJE is agnostic. It takes scores from a cheap thing and scores from an expensive thing, and how you obtain those scores is left to the user to decide.
Cool. Harsha, I saw there are also other questions from you, but I really want to get to maybe one of Crystal's question. There's one question from...
Sorry, I just wanted to add context for that earlier thing. So I attended an interview and they asked me to think about evals for Notebook LM. How would you do evals for, the output that comes from Notebook LM, audio, images, slides, text, and this just one. That's the motivator of the question. That's all I wanted to.
I see. And as I shared in the chat, we have an upcoming lightning lesson from a senior researcher at Google DeepMind, and he will speak to exactly what you are asking, Harsha, how to evaluate voice AI, and he will use Notebook as a use case in that lightning lesson. So that is going to be on Tuesday next week. Cool. There's also a couple questions from Crystal. Let me see, I'm trying to see which one we want to address to first. Crystal asked, how do you decide if you need to keep it simple in how deep to go with AI evals versus where you must use it? What is considered over-engineering?
Yeah, I mean, I'm sure you have probably even better developed thoughts on this than I do, but my approach is it's very pragmatic, which is to say you always want to start with the simple thing, and the simple thing will probably break. But when it does break, you'll have great information for how to increase the complexity. So I think you should always resist the temptation to make things complex before you've actually seen the failure that motivates it.
Yep. And I would also like to add to that, we also share this in our course, but in a nutshell, there are different use cases for AI evals. It is needed in different phases of an AI project. When you started developing for the AI product or AI, you should also start planning for AI evals from day one. So think it as evals. AI evals are tests, unit tests, or regression tests for a traditional software project. So with AI product, what we are testing is not just the logic in the code, but also the AI behavior. So that's what we do a lot in AI evals, is probing the AI behavior patterns. So you can use AI evals to guide your development, which I call evaluation-driven development, a concept similar to test-driven development. And before release, you will also need AI evaluations to act as your release gates. And because it's a different use case, you may have different needs or criteria as compared to when you need it for supporting the development. And also, after the deployment, you will still continuously iterating your product and adding enhancements to it. And at that time, AI Evals is a great tool for CI/CD. So I hope that addresses your question. We have, let's see if we can squeeze in one more question. There's one question from Wayne and asking so rubric is critical. Do you have any recommendation of how to develop such a rubric?
Yeah, so I'm certainly interested in what Stella has to say about this, but my mental model for thinking through this is really using the process of human labeling to help develop thoughts on the proper way of evaluating or the proper way of structuring the evaluation. And so, if you have a coding output, right, just thinking about what process am I going through and what considerations am I taking into account, and doing your best as you go through that labeling process to document that and use that as a starting point for your rubric. That's kind of where I would start.
And I would say from my experience, defining the rubric is critical, and the step before that is also very critical. That is defining your metrics to identify what are the failure modes, potential failure modes with your AI products. And also this is what I call similar, I make a lot of comparison analogy between AI evals and software testing. With AI evals, when you define the metrics, think of, again, potential failure modes and also things similar or concepts similar to the orthogonal defect classification method in software testing. And also because we're using LLM-as-Judge, this is the most popular method in industry in AI evals practice today. So you want to make sure that the metric is small enough and the rubric is small enough for LLM, for the judge model, and also the rubric is clear and easy to follow for judge models. Because at the end of the day, LLM-as-Judge, this method works because the language models, the large language models, are able to follow instructions. But instruction following, again, that is also one eval matrix. And we all know that models do not follow instructions all the time. So make sure that the rubrics are simple enough, clear, and easy to follow by a judge model. I hope that addresses the question. Cool. We're already over time. I want to be respectful of Addie's time. I see a lot of great questions in the chat. I also shared our calendar link. If you have practical questions in AI Evals or just curious about AI Evals, this trending topic, feel free to book time with us. And we also have upcoming cohorts in February in about 2 weeks. Our course is a 2-week cohort. We have one session on Saturday, one session on Sunday for 2 weeks. And in that course, we share a lot of practical tips of how to do AI evals, starting from getting buy-ins of your stakeholders and all the way to what you do after release, after deployment, and how to connect analytics to the AI evaluations, to the offline AI evaluations you do. So with that, thanks everyone for joining us today and great questions. We have more upcoming lightning lessons. We do regularly. Again, AI evals is a fast evolving space, and there are still a lot of practices that are taking shape. So we constantly invite researchers and practitioners, Addie, to join us on Maven Lightning lessons on these free webinars to share their latest learnings and also their latest development in AI evals. Cool. That's everyone.
And I'll just say, first of all, thanks so much for tuning in. And if anyone's interested in trying out CJE for themselves, feel free to connect on LinkedIn. I'd be happy to help talk you through anything that's confusing.
Thank you, Eddie. So with that, thanks everyone. Have a great rest of your day. Happy Friday again, and have a great weekend ahead. Bye-bye.